Resources. This chapter covers how Spring handles resources and how you can work with resources in Spring. It includes the following topics. Introduction, Java Standard Java.NET, URL class and standard handlers for various URL prefixes, unfortunately, are not quite adequate enough for all access to low-level resources. For example, there is no standardized URL implementation that may be used to access a resource that needs to be obtained from the class path or relative to a servlet context. While it is possible to register new handlers for specialized URL prefixes, similar to existing handlers for prefixes such as HTTP, this is generally quite complicated, and the URL interface still lacks some desirable functionality, such as a method to check for the existence of the resource being pointed to. The Resource Interface, Spring's resource interface located in the org.springframework.core.io. Package is meant to be a more capable interface for abstracting access to low-level resources. The following listing provides an overview of the resource interface. See the Resource Java doc for further details. Public interface resource extends input, stream, source. Boolean exists. Boolean is readable. Boolean is open. Boolean is file. URL getURL throws IO exception. URI getURI throws IO exception. File getFile throws IO exception. Readable. Byte. Channel readable channel throws IO exception. Long content length throws IO exception. Long last modified throws IO exception. Resource create relative string relative path throws IO exception. String get. File name. String get. Description. As the definition of the resource interface shows, it extends the InputStreamResource interface. The following listing shows the definition of the InputStreamResource interface. Public interface input, stream, source. Input, stream get input stream throws IO exception. Some of the most important methods from the resource interface are: 1. Get input stream, locates and opens the resource, returning an input stream for reading from the resource. It is expected that each invocation returns a fresh input stream. It is the responsibility of the caller to close the stream. 2. Exists, returns a Boolean indicating whether this resource actually exists in physical form. 3. Is open, returns a Boolean indicating whether this resource represents a handle with an open stream. If true, the input stream cannot be read multiple times and must be read once only and then closed to avoid resource leaks. Returns false for all usual resource implementations, with the exception of input, stream, resource. 4. Get description, returns a description for this resource, to be used for error output when working with the resource. This is often the fully qualified file name or the actual URL of the resource. Other methods let you obtain an actual URL or file object representing the resource, if the underlying implementation is compatible and supports that functionality. Some implementations of the resource interface also implement the extended writable resource interface for a resource that supports writing to it. Spring itself uses the resource abstraction extensively, as an argument type in many method signatures when a resource is needed. Other methods in some Spring APIs, such as the constructors to various application context implementations, take a string which in unadorned or simple form is used to create a resource appropriate to that context implementation or, via special prefixes on the string path, let the caller specify that a specific resource implementation must be created and used. While the resource interface is used a lot with Spring and by Spring, it is actually very convenient to use as a general utility class by itself in your own code, for access to resources, even when your code does not know or care about any other parts of Spring. While this couples your code to Spring, it really only couples it to this small set of utility classes, which serves as a more capable replacement for URL and can be considered equivalent to any other library you would use for this purpose. The resource abstraction does not replace functionality. It wraps it where possible. For example, a UrlResource wraps a URL and uses the wrapped URL to do its work. Built-in resource implementations. Spring includes several built-in resource implementations. For a complete list of resource implementations available in Spring, consult the All Known Implementing Classes section of the Resource Java doc. UrlResource. UrlResource wraps a java.net URL and can be used to access any object that is normally accessible with a URL, such as files, an HTTPS target, an FTP target, and others. All URLs have a standardized string representation, such that appropriate standardized prefixes are used to indicate one URL type from another. This includes file, for accessing file system paths, HTTPS, for accessing resources through the HTTPS protocol, FTP, for accessing resources through FTP, and others. A UrlResource is created by Java code by explicitly using the UrlResource constructor but is often created implicitly when you call an API method that takes a string argument meant to represent a path. For the latter case, a Java Beans property editor ultimately decides which type of resource to create. If the path string contains a well-known, to property editor, that is, prefix, such as ClassPath, it creates an appropriate specialized resource for that prefix. However, if it does not recognize the prefix, it assumes the string is a standard URL string and creates a UrlResource. ClassPathResource. This class represents a resource that should be obtained from the class path. It uses either the thread context class loader, a given class loader, or a given class for loading resources. This resource implementation supports resolution as a java.io file if the ClassPathResource resides in the file system but not for ClassPathResources that reside in a jar and have not been expanded by the servlet engine or whatever the environment is, to the file system. To address this, the various resource implementations always support resolution as a java.net URL. A ClassPathResource is created by Java code by explicitly using the ClassPathResource constructor but is often created implicitly when you call an API method that takes a string argument meant to represent a path. For the latter case, a Java Beans property editor recognizes the special prefix, ClassPath, on the string path and creates a ClassPathResource in that case. FileSystemResource. This is a resource implementation for java.io file handles. It also supports java.nio.file.path handles, applying Spring's standard string-based path transformations but performing all operations via the java.nio.file.files API. For pure java.nio.path.path-based support, use a path resource instead. FileSystemResource supports resolution as a file and as a URL. PathResource. This is a resource implementation for java.nio.file.path handles, performing all operations and transformations via the Path API. It supports resolution as a file and as a URL and also implements the extended writable resource interface. PathResource is effectively a pure java.nio.path.path-based alternative to FileSystemResource with different create relative behavior. ServletContextResource. This is a resource implementation for servlet context resources that interprets relative paths within the relevant web application's root directory. It always supports stream access and URL access but allows java.io File access only when the web application archive is expanded and the resource is physically on the file system. Whether or not it is expanded and on the file system or accessed directly from the jar or somewhere else like a database, which is conceivable, is actually dependent on the servlet container. InputStreamResource. An input stream resource is a resource implementation for a given input stream. It should be used only if no specific resource implementation is applicable. In particular, prefer ByteArrayResource or any of the file-based resource implementations where possible. In contrast to other resource implementations, this is a descriptor for an already opened resource. Therefore, it returns true from is open. Do not use it if you need to keep the resource descriptor somewhere or if you need to read a stream multiple times. ByteArrayResource. This is a resource implementation for a given byte array. It creates a byte array input stream for the given byte array. It is useful for loading content from any given byte array without having to resort to a single-use input stream resource. The ResourceLoader Interface. The ResourceLoader Interface is meant to be implemented by objects that can return, that is, load, resource instances. The following listing shows the ResourceLoader Interface definition. Public Interface Resource, Loader. Resource get resource string location. Class, Loader get, class, Loader. All application contexts implement the ResourceLoader interface. Therefore, all application contexts may be used to obtain resource instances. When you call getResource on a specific application context, and the location path specified doesn't have a specific prefix, you get back a resource type that is appropriate to that particular application context. For example, assume the following snippet of code was run against a ClassPathXML application context instance. Resource template equals ctx.getResource /resource/path/my template.txt. Against a ClassPathXML application context, that code returns a ClassPathResource. If the same method were run against a FileSystemXML application context instance, it would return a FileSystemResource. For a web application context, it would return a ServletContextResource. It would similarly return appropriate objects for each context. As a result, you can load resources in a fashion appropriate to the particular application context. On the other hand, you may also force ClassPathResource to be used, regardless of the application context type, by specifying the special ClassPath prefix, as the following example shows. Resource template equals ctx.getResource ClassPath /resource/path/my template.txt. Similarly, you can force a UrlResource to be used by specifying any of the standard java.net URL prefixes. The following examples use the file and HTTPS prefixes. Resource template equals ctx.getResource file /some/resource/path/my template.txt. Resource template equals ctx.getResource HTTP URL. The following table summarizes the strategy for converting string objects to resource objects. ClassPath. ClassPath com/myapp/config.xml. Loaded from the ClassPath. File. File:/data/config.xml. Loaded as a URL from the file system. See also FileSystemResource Caveats. HTTPS. HTTP URL. Loaded as a URL. None. /data/config.xml. Depends on the underlying application context. The ResourcePatternResolver Interface. The ResourcePatternResolver Interface is an extension to the ResourceLoader Interface which defines a strategy for resolving a location pattern, for example, an ant-style path pattern, into resource objects. Public interface ResourcePatternResolver extends ResourceLoader. String classpath underscore all underscore URL underscore prefix equals classpath. Resource, get resources string location pattern, throws IO exception. As can be seen above, this interface also defines a special classpath, resource prefix for all matching resources from the class path. Note that the resource location is expected to be a path without placeholders, in this case, for example, classpath/config/beans.xml. jar files or different directories in the class path can contain multiple files with the same path and the same name. See Wildcards in Application Context Constructor Resource Paths and its subsections for further details on wildcard support with the class path, resource prefix. A path in ResourceLoader, for example, one supplied via ResourceLoaderAware semantics, can be checked whether it implements this extended interface too. Path Matching ResourcePatternResolver is a standalone implementation that is usable outside an application context and is also used by ResourceArray Property Editor for populating resource bin properties. Path Matching ResourcePatternResolver is able to resolve a specified resource location path into one or more matching resource objects. The source path may be a simple path which has a one-to-one mapping to a target resource, or alternatively may contain the special class path, prefix and/or internal ant-style regular expressions, matched using springs.org.springframework.util.antPathMatcher utility. Both of the latter are effectively wildcards. The default resource loader in any standard application context is in fact an instance of Path Matching ResourcePatternResolver which implements the ResourcePatternResolver interface. The same is true for the application context instance itself, which also implements the ResourcePatternResolver interface and delegates to the default path matching ResourcePatternResolver. The ResourceLoaderAware Interface. The ResourceLoaderAware Interface is a special callback interface which identifies components that expect to be provided a resource loader reference. The following listing shows the definition of the ResourceLoaderAware Interface. Public Interface ResourceLoaderAware. Void set ResourceLoader. When a class implements ResourceLoaderAware and is deployed into an application context as a Spring-managed bin, it is recognized as ResourceLoaderAware by the application context. The application context then invokes set ResourceLoader, supplying itself as the argument. Remember, all application contexts in Spring implement the ResourceLoader interface. Since an application context is a resource loader, the bin could also implement the application context-aware interface and use the supplied application context directly to load resources. However, in general, it is better to use the specialized ResourceLoader interface if that is all you need. The code would be coupled only to the resource loading interface, which can be considered a utility interface, and not to the whole Spring application context interface. In application components, you may also rely upon auto-wiring of the resource loader as an alternative to implementing the ResourceLoaderAware interface. The traditional constructor and by type auto-wiring modes, as described in auto-wiring collaborators, are capable of providing a resource loader for either a constructor argument or a setter method parameter, respectively. For more flexibility, including the ability to auto-wire fields and multiple parameter methods, consider using the annotation-based auto-wiring features. In that case, the resource loader is auto-wired into a field, constructor argument, or method parameter that expects the resource loader type as long as the field, constructor, or method in question carries the auto-wired annotation. For more information, see Using it auto-wired. To load one or more resource objects for a resource path that contains wildcards or makes use of the special class path, resource prefix, consider having an instance of ResourcePatternResolver auto-wired into your application components instead of ResourceLoader resources as dependencies. If the bin itself is going to determine and supply the resource path through some sort of dynamic process, it probably makes sense for the bin to use the ResourceLoader or ResourcePatternResolver interface to load resources. For example, consider the loading of a template of some sort, where the specific resource that is needed depends on the role of the user. If the resources are static, it makes sense to eliminate the use of the ResourceLoader Interface or ResourcePatternResolver Interface completely, have the bin expose the resource properties it needs, and expect them to be injected into it. What makes it trivial to then inject these properties is that all application contexts register and use a special Java Beans property editor, which can convert string paths to resource objects. For example, the following MyBin class has a template property of type resource. Public class MyBin. Private resource template. Public set template resource template. This.template equals template. // In an XML configuration file, the template property can be configured with a simple string for that resource, as the following example shows. Note that the resource path has no prefix. Consequently, because the application context itself is going to be used as the resource loader, the resource is loaded through a ClassPathResource, a FileSystemResource, or a ServletContextResource, depending on the exact type of the application context. If you need to force a specific resource type to be used, you can use a prefix. The following two examples show how to force a ClassPathResource and a UrlResource, the latter being used to access a file in the file system. If the MyBin class is refactored for use with annotation-driven configuration, the path to myTemplate.txt can be stored under a key named template.path, for example, in a properties file made available to the Spring environment. See environment abstraction. The template path can then be referenced via the @value annotation using a property placeholder. See using @value. Spring will retrieve the value of the template path as a string, and a special property editor will convert the string to a resource object to be injected into the MyBin constructor. The following example demonstrates how to achieve this. @component. Public class MyBin. Private final resource template. Public MyBin @value $template.path, resource template. This.template equals template. // If we want to support multiple templates discovered under the same path in multiple locations in the class path, for example, in multiple jars in the class path, we can use the special class path prefix and wildcarding to define a templates.path key as classpath /config/template/text. If we redefine the MyBin class as follows, Spring will convert the template path pattern into an array of resource objects that can be injected into the MyBin constructor. @component. Public class MyBin. Private final resource, templates. Public MyBin @value $templates.path, resource, templates. This.templates equals templates. // Application contexts and resource paths. This section covers how to create application contexts with resources, including shortcuts that work with XML, how to use wildcards, and other details. Constructing application contexts. An application context constructor, for a specific application context type, generally takes a string or array of strings as the location paths of the resources, such as XML files that make up the definition of the context. When such a location path does not have a prefix, the specific resource type built from that path and used to load the bin definitions depends on and is appropriate to the specific application context. For example, consider the following example, which creates a class, path, XML, application, Context. Application context CTX equals new class path XML application context conference/app context.xml. The bin definitions are loaded from the class path because the ClassPathResource is used. However, consider the following example, which creates a file system XML application context. Application context CTX equals new file system XML application context conference/app context.xml. Now the bin definitions are loaded from a file system location, in this case, relative to the current working directory. Note that the use of the special class path prefix or a standard URL prefix on the location path overrides the default type of resource created to load the bin definitions. Consider the following example. Application context CTX equals new file system XML application context classpath conference/app context.xml. Using file system XML application context loads the bin definitions from the class path. However, it is still a file system XML application context. If it is subsequently used as a resource loader, any unprefixed paths are still treated as file system paths. Constructing class path XML application context instances shortcuts. The class path XML application context exposes a number of constructors to enable convenient instantiation. The basic idea is that you can supply merely a string array that contains only the file names of the XML files themselves, without the leading path information, and also supply a class. The class path XML application context then derives the path information from the supplied class. com/examples/services.xml, repositories.xml, messenger service.class. The following example shows how a class path XML application context instance composed of the beans defined in files named services.xml and repositories.xml, which are on the class path, can be instantiated. Application context CTX equals new class path XML application context new string. Services.xml, repositories.xml, messenger, service.class. See the class path XML application context Javadoc for details on the various constructors. Wildcards in application context constructor resource paths. The resource paths in application context constructor values may be simple paths, as shown earlier, each of which has a one-to-one mapping to a target resource or, alternately, may contain the special class path, prefix or internal ANT style patterns, matched by using Spring's Path Matcher utility. Both of the latter are effectively wildcards. One use for this mechanism is when you need to do component-style application assembly. All components can publish context definition fragments to a well-known location path, and, when the final application context is created using the same path prefixed with class path, all component fragments are automatically picked up. Note that this wildcarding is specific to the use of resource paths in application context constructors, or when you use the Path Matcher utility class hierarchy directly, and is resolved at construction time. It has nothing to do with the resource type itself. You cannot use the class path prefix to construct an actual resource, as a resource points to just one resource at a time. ANT-style patterns. Path locations can contain ANT-style patterns, as the following example shows. /webinf context.xml com/mycompany/application context.xml file c:/some/path/context.xml classpath com/mycompany/application context.xml. When the path location contains an ANT-style pattern, the resolver follows a more complex procedure to try to resolve the wildcard. It produces a resource for the path up to the last non-wildcard segment and obtains a URL from it. If this URL is not a jar URL or contain a specific variant, such as zip, in WebLogic, or star in WebSphere, and so on, a java.io file is obtained from it and used to resolve the wildcard by traversing the file system. In the case of a jar URL, the resolver either gets a java.net.jar connection from it or manually parses the jar URL and then traverses the contents of the jar file to resolve the wildcards. Implications on portability. If the specified path is already a file URL, either implicitly because the base resource loader is a file system one or explicitly, wildcarding is guaranteed to work in a completely portable fashion. If the specified path is a ClassPath location, the resolver must obtain the last non-wildcard path segment URL by making a ClassLoader.getResource call. Since this is just a node of the path, not the file at the end, it is actually undefined, in the ClassLoader JavaDoc, exactly what sort of a URL is returned in this case. In practice, it is always a java.io file representing the directory, where the ClassPathResource resolves to a file system location, or a jar URL of some sort, where the ClassPathResource resolves to a jar location. Still, there is a portability concern on this operation. If a jar URL is obtained for the last non-wildcard segment, the resolver must be able to get a java.net.jar connection from it or manually parse the jar URL to be able to walk the contents of the jar and resolve the wildcard. This does work in most environments but fails in others, and we strongly recommend that the wildcard resolution of resources coming from jars be thoroughly tested in your specific environment before you rely on it. The ClassPath prefix. When constructing an XML-based application context, a location string may use the special ClassPath prefix, as the following example shows. Application context CTX equals new ClassPath XML application context ClassPath conference/app context.xml. This special prefix specifies that all ClassPath resources that match the given name must be obtained. Internally, this essentially happens through a call to ClassLoader.getResources, then merged to form the final application context definition. The wildcard ClassPath relies on the getResources method of the underlying class loader. As most application servers nowadays supply their own class loader implementation, the behavior might differ, especially when dealing with jar files. A simple test to check if ClassPath works is to use the class loader to load a file from within a jar on the ClassPath getClass. getClassLoader. getResources some file inside the jar. Try this test with files that have the same name but reside in two different locations, for example, files with the same name and same path but in different jars on the ClassPath. In case an inappropriate result is returned, check the application server documentation for settings that might affect the class loader behavior. You can also combine the ClassPath prefix with a path matcher pattern in the rest of the location path, for example, ClassPath meta-inf beans.xml. In this case, the resolution strategy is fairly simple. A ClassLoader.getResources call is used on the last non-wildcard path segment to get all the matching resources in the class loader hierarchy, and then, off each resource, the same path matcher resolution strategy described earlier is used for the wildcard subpath. Other notes relating to wildcards. Note that ClassPath, when combined with ant-style patterns, only works reliably with at least one root directory before the pattern starts, unless the actual target files reside in the file system. This means that a pattern such as ClassPath XML might not retrieve files from the root of jar files, but rather only from the root of expanded directories. Spring's ability to retrieve ClassPath entries originates from the JDK's ClassLoader.getResources method, which only returns file system locations for an empty string, indicating potential routes to search. Spring evaluates URL class loader runtime configuration and the java.class.path manifest in jar files as well, but this is not guaranteed to lead to portable behavior. The scanning of ClassPath packages requires the presence of corresponding directory entries in the ClassPath. When you build jars with Ant, do not activate the files-only switch of the jar task. Also, ClassPath directories may not get exposed based on security policies in some environments. For example, standalone applications on JDK 1.7.0_45 and higher, which requires trusted library to be set up in your manifests. See stackoverflow.com/1939457/java-JRE7U45 breaks ClassLoader get resources. On JDK 9's module path, Jigsaw, Spring's ClassPath scanning generally works as expected. Putting resources into a dedicated directory is highly recommendable here as well, avoiding the aforementioned portability problems with searching the jar file root level. Ant-style patterns with ClassPath resources are not guaranteed to find matching resources if the root package to search is available in multiple ClassPath locations. Consider the following example of a resource location. Now consider an Ant-style path that someone might use to try to find that file. Such a resource may exist in only one location in the ClassPath, but when a path such as the preceding example is used to try to resolve it, the resolver works off the first URL returned by getResource.com/mycompany. If this base package node exists in multiple ClassLoader locations, the desired resource may not exist in the first location found. Therefore, in such cases you should prefer using ClassPath with the same Ant-style pattern, which searches all ClassPath locations that contain the com.mycompany base package, ClassPath, com/mycompany//servicecontext.xml. FileSystemResource Caveats. A file system resource that is not attached to a file system application context, that is, when a file system application context is not the actual resource loader, treats absolute and relative paths as you would expect. Relative paths are relative to the current working directory, while absolute paths are relative to the root of the file system. For backwards compatibility, historical reasons, however, this changes when the file system application context is the resource loader. The file system application context forces all attached file system resource instances to treat all location paths as relative, whether they start with a leading slash or not. In practice, this means the following examples are equivalent. Application context CTX equals new file system XML application context conference/context.xml. Application context CTX equals new file system XML application context/conference/context.xml. The following examples are also equivalent, even though it would make sense for them to be different, as one case is relative and the other absolute. File system XML application context CTX equals ctx.getResourceSum/resource/path/my template.txt. File system XML application context CTX equals ctx.getResource/sum/resource/path/my template.txt. In practice, if you need true absolute file system paths, you should avoid using absolute paths with file system resource or file system XML application context and force the use of a UrlResource by using the file URL prefix. The following examples show how to do so. / actual context type doesn't matter, the resource will always be UrlResource. ctx.getResource/sum/resource/path/my template.txt. / force this file system XML application context load its definition via a UrlResource. Application context ctx equals new file system XML application context file : conference / context.xml.